Lesson 1.4, Rewriting Equations and Formulas. So let's take a look at the warm-up first. Sometimes equations have more than one unknown variable. In these types of equations, it is still possible to solve the equation for one of the variables. When solving equations with more than one unknown variable, how can you decide which operations to use to isolate one of the variables? Okay, so this would be like if you had an equation like xy equals z, and I asked you to solve for y. So think about how would you decide what to do if you had the equation xy equals z. So write about that for a second. I'll let you pause the video. Okay, so hopefully you wrote something along the lines of the fact that you've got to use inverse operations to isolate the variable. Okay, like in this little example I made up, if we were trying to solve for y, well, y is currently being multiplied by x. So if I want to isolate y, I need to divide both sides by x. So once y is by itself, I would have z over x on the other side. So that's an example of a literal equation. Okay, or something like AB plus CD equals E. Okay, let's say we want to solve for A. Okay, so you would think about what is being done to A. Well, right now A is being multiplied by B, and then it's having CD added to it. And so that's going in the order of operations. First it's being multiplied by B, and then it's having CD added to it. So we undo that, which is how we always solve equations, is we undo the order of operations. So the first thing I would need to do is subtract CD. Okay, so now that gives me AB equals E minus CD. And then if we're solving for A, now I need to divide by B on both sides. So then that would give me that A is equal to E minus CD over B. And so that's just an example of what it looks like to solve a literal equation. So the vocabulary for this lesson, we've got literal equation, an equation that has two or more variables, and then a formula. A formula shows how one variable is related to one or more other variables, and a formula is a type of literal equation. So again, pause the video and go ahead and write that down. Okay, some examples. So we're going to solve each literal equation for y. Okay, so in the first one, y has, it's being multiplied by 3, and then it has x being subtracted. So I'm going to undo those things. I'm going to add x first. So then I have 3y equals 9 plus x. And then I'm going to divide by 3. So y equals 9 plus x over 3. And you can't simplify that. You can't divide the 9 over the 3 because 3 is not divisible by x. We don't know what x is. Okay, number 2. Again, we're solving for y. So the first thing I need to do is deal with this 2x. The last thing I'll do is divide by the negative 2 that's being multiplied by the y. But right now we've got this positive 2x, so I'm going to subtract 2x from both sides, which leaves me with negative 2y equals 5 minus 2x. And then I divide by negative 2. So y equals, now I can pull this negative sign out to the front of the fraction. So negative 5 minus 2x over 2. And I mean, that's kind of optional to do that, but it's good to know. Number 3, solving for y. So I need to subtract 8x from both sides. So 20 minus 8x equals 4y. And then divide by 4. So y equals 20 minus 8x over 4. Now on this one, because 20 is divisible by 4 and 8 is divisible by 4, I can simplify. So because the reason is because if you can think of this as this, okay? And so I can divide each of these things by 4. So this is 5 minus 2x. Y equals 5 minus 2x. And so just kind of, along those same lines, like over here, you could also think of this problem as this. You know, it's kind of like doing a reverse common denominator. So this is 9 over 3 plus x over 3. Well, I can reduce that, but there's nothing I can do here. I mean, technically, that would be another answer for that problem. But I don't want anyone trying to slash the 9 over the 3 and thinking that this is the same thing as 3 plus x, because it's not.